Hi guys. Okay, sorry that took ages to start recording then. Right, here is the first video of a series of physics revision videos. Now, what I'm going to try and do is I'm going to try and do across the board for combined science and triple science. I'll just indicate when it's triple science content and then you can just sort of fast forward or whatever. Remember, there will be bits in this video which you are totally familiar with, and feel free to sort of move around between the sections. In today's video, what I want to talk about is just some faffy little bits, just get them out of the way. Lots of bits that don't really come up in the content, but skills sort of things which you need to make sure that you can do. Okay. And then if I get onto the paper one stuff, then I will. But I will try and just work through paper one first and then paper two, probably be in about 4 videos, I think. So we'll see. Right, okay. Another point to make here is that you've got clinics and boosters coming up. Please make sure that you attend clinics and boosters, and us teachers will be available in your usual lesson times. So if you're watching this at home and you are stuck in a rut with your revision, come in and make sure that you take advantage of our time as well. Okay. Right, let me share my screen. Okay, first thing I want to talk through then is I want to talk through all the prefixes. Now, fast forward this if you feel like you're sick to death of me hearing about this, but a lot of questions will end up being where you have, I don't know, it might be millimeters and we want it in meters, or it might be kilometers and we want it in meters. So there's lots of conversions in this paper. 100% this is the way that they're moving. They love a conversion, so please make sure that you are up on these. So I like to use prefixes in my way of converting. I think it's a much easier way to do it. So if I end up with I don't know, imagine it's in, I end up with a figure and it's kilometers, and I end up with 3 kilometers in my question, and I don't want it 3 kilometers. I need that to be in meters. Now, in your head, you're thinking, well, 3 kilometers is 3,000 meters. And you're right, but some of them get pretty tricky. We've got a range of different conversions. So basically, you could have a gigameter. Well, not a meter. We don't do a gigameter, but I'll do it all in meters so that you can see what I'm talking about. A megameter, a kilometer, a centimeter, a millimeter, and then we go small, micrometer, and then a nanometer. Now, the hardest thing here, guys, is making sure that you're looking at the size of, like, look, little m and big M. That's a really common mistake there. So mega is capital M and milli is little m. So I'm going to write prefixes beside these, and I just add these to my number, whatever it is, and it will just convert it for you. So saving you counting all these zeros, just try this method for me if you haven't tried it before. So this is times 10 to the 9. This is times 10 to the 6. This is times 10 to the 3, times 10 to the 2, times 10 to the, to the minus 2, times 10 to the minus 3, times 10 to the minus 6, times 10 to the minus 9. Okay, now remember, ultimately, in this case, I'm trying to get back to millimeters. I'm trying to get back to meters, sorry. So everything has to be in meters. So let's just have a look at a couple of them. So for example, distance, it has to be measured in meters, okay? Another one, time has to be measured in seconds, not milliseconds, for example, right? What else have we got? So mass has to be measured in kilograms and not grams, for example. So it will help you convert between them, but really it's mainly this sort of examples which I'm talking about now, which these prefixes will help. So for example, I have 3 kilometers in the question, and you have like a calculation question, you're writing down everything you have. So it might be, I don't know, travels a distance of 3 kilometers in a time of 5 minutes, for example. You know there that you've got some conversions which you've got to do. I don't want minutes, I need seconds. But in meters here, this prefixes are really going to help you. So instead of writing 3 kilometers, all I need to do is I need to write 3 times 10 to the 3, and that's it converted then. Okay, so knowing these prefixes will really help. Just add it to it. If you're happy going with kilometers to meters and meters to kilometers, then that's fine. But imagine it was giga, for example. So imagine it was, I don't know, there isn't a gigameter and it wouldn't give you a gigameter. However, you'd write 3. So if it was 3 gigameter, you would write 3 times 10 to the 9. Okay, now that's it. It's converted. It's sort of saying it's 3 with 9 zeros after. So try and use those with the prefixes where you can. But remember, you're looking for these conversions all the time. They're going to be everywhere. Those are the only ones that they will ever use. They like using this one at the moment, mega, and they like using milli. Okay, so just make sure that you're using those when you're talking about distances particularly. Okay, right. The next thing I wanted to go over is uncertainty. Now, in your results, imagine you're collecting results and it's a practical and you're using a ruler, for example. If I use a ruler and I'm measuring something, okay, so it's got all its divisions along the ruler like this. If I line that up, imagine I'm trying to measure this piece of string here. I'll line my ruler up against the piece of string, but unfortunately, because we're human, there is a certain amount of error in what we do. So it's not going to be perfect, my measurement. So I've got to line up this side of the ruler with this end of the string, and then I've got to find out where the string comes to on my ruler. So here, when I'm reading this end, I end up with some error, and here, wherever I'm placing it, I end up with some error. Now, I can't change that because I'm human, but what I do have to take into account sometimes in my results is the uncertainty. So imagine I have a range of results and I don't know, it says 0.36 plus, sorry, that was one result. That was round 1. And then I took it again and it was 1.56 meters. And then I took it again. These are all very, very far apart. 1.46, for example. Whatever these measurements are. Here's what we would do to find the uncertainty. So how unsure we are of these results. So this is something really that doesn't come from the content very much and it's just sort of thrown in there. So I'm just making sure that everyone knows how to do it. So if I wanted to work out the uncertainty in a set of results, what I would do is I would do the range divided by 2, and that would tell me what the uncertainty is. So my range here is from 1.36 to 1.56. That's my range. So find out what that difference is here and then divide by 2. Now let me show you a question that I have on this. Not that one. Is it this one? Not that one. This one. Here we go. Here's an example of a question. So for one set of results, the force acting through the string was 2 newtons. The student released the trolley 3 times and determined the following values for accelerations. These were acceleration measurements. Can you see how they're a bit different, all of them, because they were measurements? Calculate the uncertainty in the values of acceleration. So that's what they could ask you. It's very rare that they do, but as you can see, they do. So the uncertainty, we write it as plus or minus because it could be either side. Okay, it could be plus. We're out by a number because we're down too low or we're up too high. So we put plus or minus. Find the range between these numbers, divide by 2. Okay. All right, that's that boxed off. Just try and put that on a revision card or something and make sure you remember it. Right, the next thing is resolution. Okay, now resolution of a device. What it means is basically it's saying how precisely is it measuring. Now, let me show you back on my questions. Okay. Here we go, we've got a protractor. The student investigated the refraction of light by a glass block. Figure 1 shows the protractor used to measure the angles of incidence, angles of refraction. What is the resolution of the protractor used to measure the angles? So basically what it's saying is what is the smallest division on here? How precisely is it measuring? So when you see resolution, it's just how precise it is. And be careful because I've seen people before now where it's like a scale like this and there'll be an arrow pointing towards us and people often just read where the arrow is. Don't do that. When it says resolution, it means how precisely is it measuring. So here it's reading to every single 1 degree. So the answer to this one would be 1 degree. Okay, so that's resolution boxed off as well. Okay, so the next thing then I wanted to talk about is peer review. You might see this and you might say, why do scientists peer review each other's work? And you've got to make sure that you get this word in here, guys, valid. Okay, to make sure that what they're saying is valid. It's checking the validity of it. So again, if I show you a type of question so you can see what I'm talking about, where would it be? Yeah, this one. Here we go. So new scientific observations indicate that many galaxies rotate too quickly for the known mass of the star they contain. So this is a space physics one. Doesn't matter though. This type of thing still could. So the scientists have come up with some observations basically. Why is it important that new scientific observations are peer reviewed? So either to check the observations are correct, to identify control variables, or to provide more proof. So basically on F, we're looking to see that the observations are correct. Okay, so you're looking to see that the observations are correct. So it's just to check and see that they're valid as well. So if you're ever asked to write something, then say validity to check the validity, how correct they are. But there it's just a tick box, so to check the observations are correct. Okay, right, let's go back. So we've done peer review as well. What else did I want to talk about? Repeats. Okay. It might ask you why you do repeats, or in a practical situation, you might say, I'm going to do repeats. So, you know, when you're doing a 6-mark question and you're talking about what you're going to do, and you might mention, oh, I'm going to do some repeats as well. Okay. So a sentence which needs to come with this is this. It might be along the lines of, why do we do repeats? Or maybe you're just stating that you are doing repeats and this is what you're going to do. But what we do is we do repeats, maybe 3, okay? Then we calculate a mean, and you must say that. So I'm going to calculate my mean. Why am I doing this? It's to reduce the effects of random errors. Okay. And finish with make my results more accurate. Ultimately, if you end up with results like this on a graph, for example, okay, and if they're far away from the line, then they're not very precise. Okay, they're all everywhere, all across. But basically, the closer it is to the line, okay, the more accurate it is. It's closer to the true value. Okay. Yeah, so we want it as close to the true value as possible. So that's what we mean when we say accurate, for example. So repeats, calculate a mean, reduce the effects of random errors, and make my results more accurate. Okay, and of course you'd remove anomalies, wouldn't you, before you did your graph, and if you saw any on the graph. Okay, another thing, if I end up with a graph that looks like this, okay, doesn't matter what it is. Imagine it's, I know, current and voltage, for example. This here, because the line is straight, I can say it's proportional. Okay. If I end up with a graph like this, let me just change colours. Actually, I'll do it on the same one. If I end up with a graph like this, it's directly proportional. And what's the difference? So if it asks you in a question, how do you know if data is directly proportional? Okay, it has to be a straight line that's through the origin. Okay, so a straight line through the origin, and that is what directly proportional means. Sorry about my writing. Okay, all right, so I'm touching on just some little finicky little bits here that I just want to make sure that you are all right with. Okay, the next thing I'm going to talk about then, and last thing I'm going to talk about, in fact, I'm going to talk about error as well. Let's talk about errors. Okay, there's 2 types of errors. There's systematic and there is random. Now, this is basically the random error is human error. Okay, it's things you can reduce the random error by doing repeats, like we've just said. So how would we get rid of this? We would do repeats. Okay, that's what we want to do. But systematic errors, what are we talking about here? These are things in your method. So these are things that can be improved in your method. For example, a non-zero error or parallax error. Okay, so when I say parallax error, what I mean is this. Imagine I have a, that's a ridiculous drawing. Imagine I have a test tube, not a test tube, measuring cylinder. Okay, and here's my scale like this. And I have my water line, which is up to here. Okay, and what I must make, if I'm looking from up here, then I'm going to end up, my line of sight is going to end up looking at that water. And will it be too high or too low? Let me think about this. It's going to appear too high above the line that it should actually be. If I get down on eye level like this, however, it will be much better. So this here, where it's actually where you're viewing it so that it looks too high or too low on the line, is called a parallax error. Now, I don't want you to call it reading error anymore, because yeah, it is a reading error, but I want you to specifically say parallax error, because more often than not in a mark scheme, they're looking for that parallax error. So please mention that when talking about reading errors. You might be talking about a practical that you're doing, or you might be talking about, it might be just an individual question that's come up in the exam about reading errors, okay? It's parallax error. But anything to do with your method that you could change, okay, so I could change from here to here, or it might be a non-zero. So for example, if I have some top pan balance, okay, remember you're not saying scales. Scales is a bad word. You're not going to say that. You can say top pan balance or balance. Balance scales is okay, but top pan balance is better. Imagine I have my top pan balance, and before I've even put anything on it, it's reading 0.01 grams or something like that. That's a non-zero error. It means that if I don't press 0 at the beginning, whatever I put on here is going to be 0.01 grams too heavy because it's already reading something. So you've got to make sure that you zero it to begin with. But if you had a list of results and you forgot to zero it, you just have to take this off, wouldn't you? You'd have to take it off all of your results to make sure that it was fair. So that's a non-zero error. That's a systematic error. Something in your method that you can change, something that you're doing wrong. For example, if you're looking at springs, okay, and if you're looking at a force extension graph, okay, and you want to create force extension graph like this, you're going to be measuring the extension using a ruler. Okay, but if you're measuring the original length of the spring as well as the extension of the spring, then that's a systematic error. You're not supposed to be measuring the original length. You only want the extension of the spring at the end. So that's an example of a systematic error. Random error, human error. We do repeats to get rid of random error, don't we? Okay. Okay. There's lots of different errors in practicals that you need to sort of try and pull out when you're writing your 6 markers about practicals as well. Last thing I want to talk about then is practicals. Practical questions. Okay, usually where it's 6 marks. Okay. There's just a list of things here I want you to get onto a revision card of some sort, that when you are writing about any practical, you list all of these things. You have to have mentioned all of these things. This is like a rule book for practicals, okay? Right, first thing is this. I would always draw a diagram. Okay, if there is no diagram, draw a diagram and label it. Don't spend your lifetime drawing it, okay? But just so that it's clear and the examiner can see what you're talking about. If it tells you, how would you do this practical? How would you set it up? Do them a little drawing if you can, okay? Ruler and a pencil would be much better. So diagram and label. You're going to tell me what the variables are. So the independent variable, the dependent variable, the control variables. Just to recap, this is what we change each time. This is what we're testing, basically. This is what we're measuring. Okay, and this is what we're keeping the same to make sure that it's a fair test and it's valid. Okay, and then after that, we are going to make sure, so we're going to describe the practical. we've got all our variables. What we're going to do now, you need to tell me a range. So for example, if I was doing resistance of a wire, I'm going to move my crocodile clips every 10 centimeters, and I'm going to do this for a meter. Okay. So I want to know the range and the intervals. Okay. So what are you going to be testing over? You must mention all of your equipment. So for example, even if it's something like I will measure the length of the string or whatever it is, right? Using a ruler. I will measure the volume of the water. Oh, that's another thing as well. The word amount is banned as well. So you can't say scales and you can't say amount. Amount is too vague. We want to say volume, for example, okay, or the length. Okay, so you're going to be very specific about what it is that you're measuring. Amount is no good. Don't say that word. So you must mention all of your equipment. Then are you going to do repeats? Okay, then you might mention the whole mean thing and then talking about reducing the effects of random errors. Okay, for example, making your results more accurate. Then are you going to do you need an equation? You know, do you have to calculate something at the end in order to get what you need? Are you going to do a graph? I feel like I'm missing something. Oh, risks and safety. So if you're going to outline a hazard or a risk, then you're going to then say how would you prevent it? Okay, so I'm going to use heavy masses. The risk is that they could fall down onto my toe. How am I going to reduce this? Make sure your feet are out the way and make sure there's a cushion under the masses or something like that. Okay. So if you try and stick, guys, to this rule of thumb that you're mentioning all of these things in every practical, then you're good to go. I hope I haven't missed anything off there. Let me just have a quick review. So we've got diagram, variables, range, intervals, mention all your equipment, repeats, equation, graph, risk. I think I've got everything there. Should we have a quick look at a practical question as well, just to make sure? So let's go back to here. And if I just search in required practicals, let's get rid of that. So let's just pick anything. I don't know. Let's go for the density one, for example. No, in fact, let's go for one with more of a range. Let's go for resistance of a wire. Okay. All right. So this one, a student plotted a graph of resistance against. Let's describe a method a student could have used to collect the data to plot the graph. Let's have a quick look. So measure the length of the wire using a ruler. Look. Okay. Length varied by moving the crocodile clips. So you've got to really tell them, you've got to be clear, because you've got to, as if someone could just pick it up and repeat this experiment. Current measured using an ammeter, the potential difference measured using a voltmeter. Calculate the resistance. Look, there's the equation. It hasn't come up with the variables, but actually that would only help because it would indicate what you're measuring and what you're not. Record current and PD for different lengths. Repeat the readings. Calculate a mean. Yeah. Remove any anomalous readings. We didn't say that, but we should add that to our list in a moment. Ensure values of current are low to minimize heating of the wire. So how to reduce the error. That's another thing. That's what I forgot. Let's go back over here. Okay. Errors. Possible error, how to reduce. Okay, and what did we miss after repeats as well? Emit any anomalous results. Okay, so get rid of any anomalous results. It's omit, isn't it? Have I got that right? Anyway. Yes, so get rid of any anomalous results. Errors, you know, for example, in that one, when I was talking about the resistance of a wire one, if I don't, let's find it again. if I don't turn it off in between in the practical, so if I go back to the question, see here, I'll have this all set up. And if I don't keep unplugging it from the battery, what will happen is it'll all start to heat up in these wires and that will cause more resistance. So in between, what do I do about it? I unplug it whilst I'm not reading. Otherwise, this wire gets really hot. And if it gets hot, we get more resistance. And then that's going to skew our results, isn't it? Okay. So really, that's a pretty fail-safe list that you have there. Put it onto a revision card, and for every practical that there's 10 for combined science and there's 12 for triple science. Do a little card where you mention all those things for each of the practicals. So that can be your task for this week. Write up all the practicals, watch a little video on each one. If you just type into Google GCSE required AQA required practical, okay, and you can find any of them on there. Remember, free science lessons are really good as well. I don't think they go through the practicals, but they're really, really good for taking some notes from. In terms of your revision now, guys, let me just stop sharing. In terms of your revision, this is what I would be doing. Don't make notes of things you already know. The temptation to just keep writing, oh, yeah, okay, I know about that, and you're just writing, making aimless notes. Don't do that, okay? I want you now to just be doing questions, okay? And then if you don't know something and you think, I've forgotten all that, you're going to have your computer open at the time as well, and you might go to that and do a bit of research, watch a video on it. Okay, I get it now. Come back to your paper. Have the mark scheme there, annotate it. So, right, okay, did I get it right or wrong? Annotate it to death. Then, after you've done a little period of that, get an A3 sheet of paper. And for paper 1, only the stuff that you genuinely think, oh, I'm going to struggle remembering that. Only that stuff, nothing else. That will go on your A3 sheet of paper. And you'll put it, imagine it's about energy, okay? If it's about energy, I'm going to put it in red. If it's about electricity, I'm going to put it in yellow or something, or highlight it. So guys, when you're walking into your exam, you will have one A3 sheet of paper. You can come get A3 from us. We've got loads of it here. One A3 sheet of paper, which has just the stuff which you think you might forget. Okay, just the stuff you find hard. I don't want to see reams and reams of, these cards that you just keep going through again and again. There's stuff on there that will be there you already know. You don't need that. What you need is one sheet of paper, like a crib sheet, that you can just walk around with on the day of the exam and be like, right, this is my thing. This is the stuff I really do need to know. So anything from this video today as well, which you're going to forget, like your prefixes, for example, get them on that paper. Do one for paper 2, do one for paper 1. Sorry, paper 1 and one for paper 2. And remember, if you do it in different colours, when you're in the exam, you will be able to visualize that piece of paper and it will come back to you quicker. You'll be like, energy stores, kg of cement, or whatever you're thinking of. And it will instantly appear to you in your brain in that color. It will help your brain recall it. Okay, so that's my exam technique, which I would think you should try. Just don't sit there making aimless notes. You should really be going in on question after question after question after question. And anything that comes up in those mark schemes, like, oh, I didn't mention thermal conductivity and I should have done, then that's going on your crib sheet. Okay, now the videos I'm going to go through now, I've been through my spec and I've started to make my predictions as to what I think is going to be on the paper. So tune in, and next video will be all starting into that paper 1 and my predictions. It'll probably go over 2 videos, I think. Okay. All right, guys, come and see me if you've got any questions. See you later.